Blueprint visual scripting, or Blueprint for short, is a super powerful tool within UE4. But what exactly is Blueprint? Blueprint in its purest form is visual scripting, and contrary to popular belief, when you are working with Blueprint, you are programming. You're just doing so in a more visual way. So typically, people tend to fall into one of two categories. You either love programming or you don't. Programmers spend their days typing in lines of code in something like Visual Studio, which looks a little bit like this, and the code that they enter executes some form of functionality within their application. Blueprint lets you execute that same functionality, however you can construct that functionality without having to touch a single line of C++ code. You do so by connecting a series of nodes together, and those nodes have some functionality already attached to them. For example, here on the right, we have a node network that enables us to change the color of a light to green whenever our application begins. It's kind of like a flowchart if you've ever created one of those. However, with Blueprint, that flowchart actually executes your functionality. Now, Blueprint is the system that enables us to create content in this visual way. The actual content that we create, however, is oftentimes referred to as blueprints, or the tangible thing that you have created through Blueprint visual scripting. So you may see the term blueprints. Just remember those are the things that we've created versus Blueprint, which is the system itself. There are many different types of blueprint that you can create, and we'll get into those a little bit later. But the best way to think about blueprints is that they act as a container for content. Okay, they can hold what we call components, or the pieces that make up our blueprints. For example, a car blueprint could contain the car's frame as a component, the wheels as a component, the engine as a component, etc. They can hold scripted functionality, but they don't have to. So back to our car blueprint, we could script some functionality that says when the gas pedal is pressed, tell the engine to move the car forward. Or we could not script any functionality. It'd still be a car with an engine, frames, and wheels. It just wouldn't know how to move. Blueprints can also hold only data, and that data can be adjusted. So once again, in our car, imagine there's a car stereo. We can change the station, turn up the volume, put in a CD, whoever does that these days. But we don't actually change the functionality of how our radio handles turning up the volume or changing stations. We let the user perform the actions, and the functionality behind the scenes takes over. Data only blueprints work in that same way. We give the user the ability to modify the blueprint, but not touch the underlying script directly. So let's take a look inside the editor at some of these examples. Inside the editor here, we're going to take a quick look at some example blueprints. The first one that we're going to look at is a blueprint door. It's just a simple door with some scripted functionality that allows us to enter this little box and open the door. So if we press play, as we approach the door opens. As we leave, it closes. This blueprint has scripted functionality on how to open the door. It also has what we call components that make up the actual blueprint. So I'm going to select the blueprint in the level here and go to Edit Blueprint to open it up. And you'll see that there's already some script in here. We're not going to get too concerned of what all the script does. All we're going to do is see that there's one section for opening the door and one section for closing the door. And on the viewport, we have all the components over here on the upper left that make up our blueprint. So we have the door frame, we have the door, and we have a trigger, which allows us to determine when the player actually enters an appropriate range for the door to open. So that's our first example blueprint. Directly to the right of that, we have a very similar looking door. However, this door does not have any script. This door simply holds the components required to make up our door. So if we go and select it and we edit it, inside the graph here, we have no script for defining how this door should open. So in fact, the door will not open if we approach it. All it has are the components that make up our door. So it has just the door frame and the actual door. Now, why would we want to do this? One particular use case, if we were making a vastly big apartment complex and it has thousands of doors, we could on each one add a door frame and a door, or we could have a blueprint that has all that set up for us and we could just make copies of that like so and place those wherever we want. And we could also set it up so that we could define what each door looks like through blueprint, etc., without actually having the functionality of scripting the door. That's one particular use case. Some other examples here that we'll look at very quickly. We have a customizable light here. Similar concept. When we approach this little trigger volume, the light will come on. So if we play, as we approach the volume, the light turns on and is green. As we exit, it turns off. So very similar concept to the door. However, this particular blueprint, as we mentioned with the door example, how we could have parameters exposed that we could modify the way the door looks, which we can do through the details panel here. We could change the light to red, for example, and we could turn it on by default if we wanted to. And as we play, now the light's red. Again, this could be a use case where we have several different lights in our level and we want to make those customizable, but we don't want to provide artists with the ability to define how lights turn on through script. We could expose parameters that allow artists to tune and tweak the way lights look, but keep that scripted functionality inside the blueprint in what we call a data blueprint, a data-only blueprint. So this is very similar to the blueprint that we just had there, except if we open this one up, we still have those properties that we can define. If we open it up, we actually don't have the graph. Okay, so this is just giving us the ability to define the data for this blueprint. Inside the actual blueprint is the scripted functionality to determine how this light actually turns on. So it works just the same. We can approach it and it turns on, and we can change what the color of the light looks like, or the brightness, or the radius, etc. Other things to know about Blueprint is that Blueprint is a compiled object-oriented visual scripting language, meaning you'll need to compile your blueprints before running them. In most cases, we're talking fractions of a second to compile as opposed to minutes for a program to compile in a programming language. Also, if you're unfamiliar with the term object-oriented, in short, it's the concept that there are objects that contain data already, and that data can be accessed, modified, or called upon from within or from another object. In much simpler terms, you can create class structures where you start with a generic class, like a vehicle class, where all vehicles know how to drive, they have gas and brake pedals and steering wheels, for example. But from that vehicle class, all the functionality from the vehicle class you can take with you into a new class called trucks, for example. A truck knows how to drive, a truck has a steering wheel, a truck has gas and brake pedals, but you can add truck-specific stuff to it, whatever that may be. Maybe it handles a little bit better off-road, for example, or has bigger tires. You wouldn't need to redo all the base vehicle stuff, and all that functionality can be applied to other types of vehicles that you'd like to create as well, such as motorcycles, cars, or maybe even golf carts. The blueprint system ties directly into the existing framework classes within UE4 as well. So there's already a bunch of C++ code created for you, wrapped up in predefined classes that you can access. This means that you don't have to start from scratch. Some of that work has already been done for you. So here we are inside the editor, and I wanted to take a moment to look at some existing classes as well as the class hierarchy inside of UE4. So whenever we create a new blueprint, we can go up to Blueprint Class to create a new blueprint. We're going to have the ability to pick a parent class, and this is where we can inherit some existing functionality from the class that we select. Most of the time, you're going to be working with actor classes here. These are objects that can be placed or spawned inside the world, as the tooltip suggests here, and you can look at the other tooltips as well to get an idea of what they are. But most of the time, whenever you're placing blueprints inside of your level, they're going to be based off the actor class. But I did want to expand all classes here to kind of show you the hierarchy and class structure that we have in place. So inside of UE4, everything derives from the object class. This is the base building block for all classes inside of UE4. There is an actor, as we mentioned. There's the actor class. If we expand that directly under actor, these are all the other things that are actors that we could place. So we have all kinds of different blueprints that we've already created, sounds, etc. But I wanted to scroll down and take a look at, let's look at pawn. So a pawn is the base class for all actors that can be possessed by players or AI. So this is the thing that you are controlling while your application is running. Also says it up here as well. It's the second one down from the list. If we expand pawn, now we have the ability to assign a character. So a character is the representation of the actual, as the name suggests, character that you're controlling inside of your levels. Now, you may or may not be controlling a character. You could be controlling a wheeled vehicle, for example. You could be spectating, which you have no physical body, but you still need to control something that you can fly around inside of an environment, which you could use a default pawn, which is a class that comes with the engine. It has no skeletal mesh. It's just an invisible thing that you can fly around inside the level. But that's kind of what I wanted to identify here, is that you can have children of classes and inherit functionality from the class above it. So we have our pawn class, which can be possessed. We have the character class, which is a character that you can actually control. And then under that, you would have all the different types of characters that you have. So if you have a fighting game with a whole bunch of different characters in it, they could all be based off of the character class and have their own functionality built in within them. Blueprint is also completely embedded within UE4, so there's no IDE to interface with. We're going to take a look at this a little bit later in the series, but you'll find all over the engine that Blueprint is embedded in everything from animation to UI to materials, and sound editing are all node-based as well. It's predominantly used throughout the engine. And at its core, blueprints work by stringing various nodes that have some functionality together and making connections, where after a compile, you'll see the results instantly. So it has a very fast iteration time. You can quickly make changes and see those changes reflected instantly. When it comes to the different types of blueprints that you'll be working with, you'll mostly be doing your blueprint work inside of the level blueprint or class blueprints. Level blueprints are a unique type of blueprint that exists per level. So if you have things in your level that you want to provide scripted functionality to, you could do that inside the level blueprint. The caveat to that, however, is any scripted functionality that you do in the level blueprint will be bound to the level that you do it in. So if you change levels, you'll have a new level blueprint that you would need to redo that script in. Or you could use class blueprints, which are more modular in that the script that you create is bound to the actual blueprint you do it in. For example, the door here, that was a class blueprint. We created all our scripted functionality inside of that class blueprint so that we can place that blueprint in any level and it would just work. If we scripted the functionality to open the door inside the level blueprint, in each new level, we would have to do that. So it's much more beneficial if you're doing things in a modular way to do those inside of the class. Another thing to note is that C++ is Blueprint and Blueprint is C++. And what I mean by that is Blueprint is built on C++ code. The backend for Blueprint is rooted in C++. So what that means is you can open up and edit blueprints in C++ if you desire. We also have a tool that will actually convert your blueprints into native C++ code as well if you'd like to do that. The other thing that is great is that blueprints and C++ work well together. So you can create C++ classes with some functionality and expose certain parameters to Blueprint so that your non-programmer types can access it and modify the parameters that you've defined. They'll be able to do this without having to touch any code. They can do it directly inside of Blueprint. So now that we've taken a look at some blueprints inside of UE4 and discussed what Blueprint is, you should have a better understanding of how it can be used to script functionality in your own applications.